Hello, Algebras, and welcome to your Chapter 1, Lesson 5 notes, Day 1. We're going to solve rational equations over the next 2 days of notes. Now, we have previously discussed that a fraction is simply a division problem. In rational equations, we are going to have and deal with fractions in multiple pieces of our equations that we're solving. So let's just remind ourselves, given this picture, the parts of a fraction. In a fraction, the top number, the numerator, is being divided by the bottom number, the denominator. The top number needs to be divided into an equal number of pieces indicated by the bottom, the denominator number. So 1 needs to be divided into 2 pieces, and we call each of those pieces 1/2 of that whole piece. Okay. Fraction bar represents division, right? Remember, I know I've shown you this in class, but a division sign, a good old-fashioned division sign, looks like this. Well, what is actually going on there? It's a fraction. Numerator divided by denominator. So, when we have more than one fraction in an equation, we look to the denominators to help us find an LCD, a least common denominator, that we can use to clear out the fractional pieces. So those of us who have that innate fear of fractions, you can stop having fear. We'll actually try to get rid of all those fractions right off the bat. So what we do to find an LCD, or a least common denominator, is that we look to both denominators and we think about the things they can both multiply to become. So I think about multiples of 9, 18, 27, 36, 45, 54, 63, etc., etc., etc. Then I also think about multiples of 4. What could 4 multiply to become? 4, 8, 12, 16, 20, 24, 28, 32, 36. When you think of something they both multiply to become, that something is my LCD, my least common denominator between 4 and 9 is 36. So, since that's the case, that would be what I used if I were to run into that in a rational equation to multiply by all my pieces. Let's think about these two fractions. Look at our denominators. So notice I don't care about what's going on in the numerators right now. What I care about is, what can 6 multiply to become? What can 3 multiply to become? The beauty is a situation like this. 3 can multiply to become 6. So actually, my LCD is already present. It's 6. Both denominators have to be able to multiply to become this value. Now, let's say there's 1, 2, 3 denominators, and one of them has a variable in it. That variable is just multiplied by the LCD of the numbers. So think first about, what can both 5 and 2 multiply to become? And by the way, sometimes it's multiplying them together. So what is 5 times 2? It's 10. Both of those things can multiply to become 10. Now we consider this x involved in the LCD, and you've got 10x as your LCD. Anytime there's a variable in the denominator, it is part of the LCD by multiplication. Okay? That's the first piece, is getting down our LCDs. If we flip our page, the next piece is using our LCD to clear out our fractions. So here's an example of that being done right here. So I'm not going to go through this example. What I'm going to do is I'm just going to dive right into my questions and show you practically how I'm doing this. But here's an example that goes right along with the procedure I'm about to follow. So in practice problem number 1, Let's look first at our denominators. Okay, I've got a denominator of 2. I've got a denominator of 5. I've got a denominator of 1, because 14 is a whole number. Now, any number over 1 is what I'm looking at here. And when I have just a whole number present and henceforth a denominator of 1, I don't worry about that involved in the LCD because 1 multiplies to become anything. So now I think about, what do 2 and 5 multiply to become? Oh, we already knew this one from a previous example. It's 10. So I take my LCD and I multiply my LCD times every piece of the equation. So the first big step is rewrite out your LCD multiplied by every single piece of the equation. It's the first big step, and you've got to do this because in every piece it might cancel differently. Because the idea here is that the LCD cancels with the denominator. So 10 divided by 2 cancels out to 5x. 10 divided by 2 cancels out to 5. 5 times x, 5x. Let's try that again in the middle. But remember this negative sign, so don't forget about this minus sign out here. In the middle, 10 cancels with 5. What's 10 divided by 5? It's 2. But what kind of 2? Negative. So it's a negative 2 times x, or negative 2x, that comes down to my next line. Now bring down your equal sign. Is there a denominator that my LCD is canceling out with over here? No. So what comes down to this next line? 140. 10 times 14, 140. So on the left, we're going to combine like terms. 5x's minus 2x's is 3x's. Bring down your equal sign and bring down your 140 we haven't dealt with yet. Now, I do know that 3 is not going to evenly divide into 140, but it will give me a repeating decimal. So, how about we get the right number into our graphing calculator? So 140 divided by 3, because I'm dividing both sides by 3 to get my x all by itself, gives me 46.6 repeating. Just put that repeating bar over your 6 and you are all set. Much like when solving proportions, which we're going to talk about in the next lesson video, much like solving proportions, you're more likely to get fraction and decimal answers out of these. So let's try this again with example 2. In example 2, 18 minus x over 6 equals 4x over 3. Now, 18 doesn't have a denominator, so we're only thinking about 6 and 3 as denominators. Can 3 multiply to become 6? Yes, it is my LCD then. 6 is my LCD because both things can multiply to become 6. So 6 times 18 minus 6 times x over 6 equals 6 times 4x. We rewrite the entire equation and multiply every single piece by our LCD. So in the front here, 6 times 18 gives me 108. In the middle, 6 divided by 6 cancels out to a 1, but it's a negative 1 times x, which is negative 1x, or just negative x in the middle. See that? That's beautiful when your LCD is one of your denominators. They just cancel out completely. Over on this side, that should have been over a 3, right? Because 6 divided by 3 cancels out to a 2, and we distribute. So do make sure you've rewritten your original equation correctly as you're multiplying each piece by the LCD. So 2 times 4x, that would be 8x. Now get all your x's together on one side of the equal sign. Bring down your 108 equals 8x's plus 1 more is 9x. And divide both sides by 9. 108 does evenly divide by 9. 108 does evenly divide by 9. And again, you can just press your division because we already had 108 right there. And divide by 9 to get 12. as our answer for x here. Okay, let's try one more together. Number 3. 3 and 5. They can both multiply to become 15. So I am going to multiply every piece of this equation by 15. 2x over 3 times 15. 15 minus 15 times x over 5 equals 15 times 7. Okay, now remember, the LCD cancels out with denominators. So 15 divided by 3, 5 is left over, and that now gets multiplied by the numerator. So I get 5 times 2x is 10x. 15 divided by 5, that cancels out to a 3, but it's negative. So negative 3 times x is negative 3x here. Bring down your equal sign. No denominator, no canceling. So we would have 15 times 7, which is 105. Combine like terms on the same side of the equal sign. 10x's minus 3x's is 7x's. Bring down your equals and your 105 and divide both sides by 7. What do we get for x? And again, you can just press your division because that was our previous answer, was 105. So 105 divided by 7 is back to 15. Let's stop right here and have you work on number 4. So stop right here. I'll zoom out so you can see the other ones. You try number 4 yourself. Pause it here. Try number 4. See if you can get that LCD and multiply it through, canceling out. When you press play again, we'll check the answer for 4, and we'll try a couple that have increased in difficulty on the next page. Okay, so I will see you in a second there, Algebra Crew.
A few moments later.
Okay, welcome back. How did you do? And make sure you're watching what your denominators are in order to figure out your LCD. So let's look at a couple more where we'll get a little bit more in depth. Starting with number 5. Okay? So if we look at number 5, we say, oh, well, we've got an x in a denominator. We've got an 8x in a denominator. We've got a 4 in a denominator. So what did I say previously about having an x in a denominator? It then has to be part of the LCD as a multiplied piece. So now just think about the other two numbers involved, 8 and 4. What can they both multiply to become? Well, 4 can multiply to become 8, and 8 multiplies by 1 to become 8. So your LCD this time is 8 times x, 8x, which is one of your denominators. So in that particular instance, it's going to cancel out fully. So we take this LCD and we multiply it by every single piece of our equation. So we rewrite every single piece. Don't forget about that minus sign right there. That's going to come into play. So in the front spot, notice we don't have an 8 in this denominator, but we do have an x. Well, since we have an x in the denominator and the numerator, that fully cancels, and just the 8 multiplies by the 2, leaving me with a 16. In the middle, full cancel, both the 8 and the x totally gone. So now you've got a negative times 3, so minus 3 right here. On the other side of the equal sign, the x is going to have to be multiplied through, but there is no x in the denominator it's canceling with. But 8 divided by 4 cancels out to a 2, so this is a 2x times 1, bring down 2x. So now you've got your like terms combined. 16 minus 3 is 13. Bring down your equal sign and your 2x. Okay, the opposite of multiplying by 2. Divide both sides by 2. Got a canceling out over on this side. We get an x of 1x. And then, of course, 13 doesn't evenly divide by 2 because it's not an even number. But we do end up with a nice terminating decimal. So x equals 6.5 here. Now, I'm going to jump down to number 7 so that we can look at one together that has 1, 2, 3 denominators that we have to consider as far as finding our LCD. But I'm going to have you try number 6 and number 8 in a second to see how well you're doing with this. So, number 7, we've got a 6, a 12, and an 8 all in our denominators. So let's think, what can all of those multiply to become? And the first instinct is look at that biggest value and see if all of the other things can multiply to become that. So 6 can multiply to become 12, but can 8 multiply to become 12? And if the answer is no on that one, okay, then we have to all multiply up. So then the next thing that comes to my mind is multiply the biggest number by 2. What's 12 times 2? It's 24. Can 8 multiply to become 24? Yup. Can 6 multiply to become 24? Yup. So our LCD is 24. See how I did that? I thought about that biggest value and I tried to use that first before I got myself frustrated. So I take my LCD and I multiply it by every single piece in the equation. So all the pieces are getting multiplied by 24. In the front piece, 24 divided by 6 cancels out to a 4. That multiplies by my x right here. 4 times x is 4x. Bring down your equal sign, and now let's try that right here. 24 divided by 12 leaves me with a 2, and 2 times 1 is 2. Just the number 2. Comes down to the next line. And then, of course, over here, 24 divided by 8 is 3. 3 times x is 3x. Now I want all my x's on one side of the equal sign, all my numbers on the opposite. So let's subtract that 3x over to the other side. And I'm so lucky because 4x minus 3x is 1x all by itself equals that number that I had left there, that 2. Okay, so I'd like to stop right here, have you pause it, and I want you to try the same method with the LCD on number 6 and on number 8. Where you've got 1, 2, 3 denominators that you're working through. So try these 2 right now, and then press play again, see if you got the right answers, and if not, we'll go through and make sure that you've tried them and gotten those answers, okay? Pause it right here. Okay, algebras, how did you do? Remember, the LCD is going to be able to be divided by anything in a denominator because it is a multiple of all of the denominators. So that's the key as to figuring out that value that you multiply by all of the pieces. Where do I think the biggest mistakes probably occurred? In number 8, what your leftover is, 30 divides by 5 evenly, you're left with 6. It has to multiply by both things in the numerator. So I have 2 things that had multiplied by that leftover of 6. Okay, just be very careful of that when you try these on tonight's homework. Okay? Please, if you have any questions, come to me on these. We will continue to do more practice on this tomorrow, and we'll talk about what's that difference between when do you have just a regular rational equation and when do you have a proportion, and what do you do differently for each one. So we'll kind of compare and contrast those and take a look at a few of those questions side by side. Okay, you have a great rest of your day. Good luck on this homework practice, and let me know if you have any questions. Bye, Algebra Crew.